Okay, and so this question says, find the area bounded by the curves y equals secant squared of x and y equals x minus 1 from 0 to pi over 4. First thing we probably want to do here is give ourselves a little bit of a sketch. Okay, and so what I know here is, and maybe I'll start with this in pencil, because it might not be obvious what secant squared looks like. So secant squared, okay, we're going to start off with cosine. So cosine is going to look something like this. Okay, and I know that it's going to go through here at pi over 2, sorry, negative pi over 2, and it's going to come up here to pi over 2. Which means ultimately the area that I'm looking for is really of interest to me right in here. Okay, just this little bit. But we'll just keep going here. So this is going to be, this will be pi, this will be negative pi, and so on. Now, when I square that, remember I'm squaring the y value, so 1 squared is going to stay the same, 0 squared will stay the same. So these points are going to stay the same. And in fact, anything that was negative, okay, a negative 1 is going to pop up to a positive 1. So I'll just connect, I'll connect these dots right here, because cosine squared is going to look something like this. I didn't do that super well, but you get the idea. And then secant squared is just going to reciprocate that, meaning that everywhere that it goes through 0, I'm going to get an asymptote. And then because this goes to 1, under that kind of reciprocal transformation here, those are going to remain invariant. So it's going to come down and then shoot up to the asymptote. So it's going to look like this. Okay, that red graph there is going to be the secant squared. Now, x minus 1 is going to be a graph that's got a slope of 1, and it's going to go through like this. And so what I'm interested in is the area in between these two functions from 0, okay, to pi over 4. So that little section right there, notice it's going to have, well, if you were to stop right there, that's a trapezoid. This isn't, because it's got that little curved surface there. So the area function, or the derivative of the area function that I'm going to set up here, is going to be the secant squared minus the other function. Okay, I'm going to do the subtraction first here. Now I'll just clean that up just a little bit by distributing the negative through. And so my area function is going to be the antiderivative of secant squared, which will just be the tangent of x, minus x squared over 2 plus x plus c, our arbitrary constant. Okay, now I'm going to evaluate that from 0 to pi over 4. And actually, I don't have to worry about breaking this up into different intervals or anything like that, because there's no crossing over there. So I really just have to evaluate this from between 0 and pi over 4. And so that will be the tangent of pi over 4 minus pi over 4 squared over 2 plus pi over 4 minus the tangent of 0 minus 0 squared over 2 plus 0 plus, oops, I forgot the plus c in both cases, even though they're going to cancel. Okay. Whoops, sorry, that went off the screen there. So here we go. Tangent of pi over 4 is 1 minus, this is going to be pi squared over 32, because I'll square the 4 here, then divide by 2, plus pi over 4. And then back here, that's just all going to be 0. And so this is my answer right here. Now, I am just going to double check the answer in the back there, just to make sure that I'm doing this to the same level. I should have checked this before I did this question here. They want us to go through and add those all together, so to get a common denominator here. So the final answer in your workbooks or your textbook actually has got a common denominator of 32. That is going to be, what is that? That's going to be 32 minus pi squared plus 8 pi. And so that's the answer that they're looking for, the unit squared.